Hello everybody and welcome to the homework helper for section 3.2. Alright, we're going to go ahead and get started with adding and subtracting binomials. So what we're going to be given here is we're given these pairs of binomials and we're going to be adding our like terms accordingly. So what we have to keep in mind is that like terms. Okay, we need to combine our like terms. So x terms can add to x terms, constant terms to constant terms. And then I don't see any here, but like x squared terms, add to x squared terms, but they don't mix. Okay, they have to go with their like, the ones that are similar to them. So when we're looking at number 1 here, we have 6x plus 3 plus 4x plus 5. Okay, so a lot of pluses in there, but make sure you're keeping in mind where these parentheses are. We've got these two batches. So this is going to be 6x plus 4x. 6 plus 4 is 10. So we have 10x. And this is going to be 3 plus 5. That's going to be 8. Okay? So it's 10x plus 8. Nice and simple. But let's maybe do a more complicated one. Okay? Let's do number 4 here. So now we have 4x minus x. Well, 4 minus 1 is going to be 3x. And then we're going to have 9 minus 2, which is going to be 7. Okay, not so bad so far. Not so bad so far. But let's maybe do a more complicated one. Let me do number 8. So I have negative 5 minus a negative 5. So that's negative 5. When we subtract a negative number, it's the same as addition. So negative 5 plus 5 is going to be 0. So I have 0 x's that cancel each other out. And then I'm going to have 8 minus 7, so the answer here is just 1. Okay. So as you go through these, make sure you're taking your time to think about it. Like, look at the way that I did it. I did 4x minus x, negative 5x minus negative 5x. You know, saying it out loud, drawing something so that it's very clear. Okay. Don't get lost in your head. Use those little physical tricks so that you can keep on top of it. Okay. Then let's go to number 10. We were given f of x plus g of x and f of x minus g of x, and it wants us to graph this. So when we're thinking about graphing them added together, okay, it's like we're going to take these lines and add them together. What we're essentially thinking about is their outputs, right? Because remember, x is the input, f of x is the output. Okay, so we're looking at the outputs, and outputs are our y. So what we're going to be doing is we're actually going to be adding the y value on the same x. Okay, so what I would do, you know, to get this started is like here's my x, right? Here's x at negative 1. Okay, here's x at negative 1. And so what I'm going to do is I'm going to add my y values together. So here I have a y value of negative 6, and here I have a y value of 1. Negative 6 plus 1 is negative 5. So this is the point at negative 5 where f of x plus g of x is happening. I'm going to do that again. Okay. Now I'm going to do it at 0. Okay, I did it at negative 1. Now I'm going to do it at 0. At 0 I have negative 4 and I have 2. So negative 4 plus 2 is going to be negative 2. So I know at 0 I'm at negative 2. Okay, now I'm going to do it at 1. Negative 2 and 3. Negative 2 and 3. That's going to be a positive 1. Okay, and we could start to see our new line take shape. It has a slope of 3. Slope of 3. Okay, let's go to 2. 0 plus 4 is 4. Slope of 3. 3. 2 plus 5 is 7. Slope of 3. Okay, 4. 4 plus 6 is 10. And we still have that slope of 3. Okay, so that's how we do that. Okay, we just look at our y values and add them together and get this beautiful brown line. Okay. It's a little sloppy. It's a little sloppy, but you'll forgive me. Okay. Do the same thing for f of x minus g of x, except this time, yeah, we're just subtracting these numbers. Okay, so so now we're going to do what's our f of x line? This is our f of x, so 4 minus 0 would put us at 4. Okay, 3 minus a negative 2 All right, 3 minus negative 2, that's 3 plus 2, that's going to be 5. Okay, so go ahead and puzzle through that to make sure that you're doing it right. All right, let's flip it on over. For the set, what we're going to be doing is we're going to be comparing simple polynomials. We're going to be looking at y equals x cubed, and y equals x to the fifth. So when we have an x of negative 1, y equals x, well, that would be, our y would be negative 1. 0 and 1, right? Y and x are the same thing. Now for this one, we are raising it to the third power. So this is negative 1 cubed, which is negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1 is positive 1 times negative 1 is negative 1. So this is going to be negative 1. 0 times itself 3 times is 0, and then 1 times itself 3 times is 1. Okay, sweet. That's easy. And then y equals x to the negative fifth. Okay, well, that's going to be negative 1 to the fifth, which is negative 1 times negative 1 times negative 1 times negative 1 times negative 1. 1, 2, 3, 4, 5. Okay? Negative 1 times negative 1 is positive 1, negative 1, positive 1, negative 1. Okay, so that equals negative 1. 0 times 0 times 0 times 0 is 0, and 1 times 1 times 1 times 1 is 1. Well, look at this. We got the exact same output for all of these. Okay? Y equals x cubed, and y equals x to the fifth. So, what are the graphs going to look like? Are they the same? Are they different? These are things I want you to puzzle back about. Okay? You need to make some assumptions based on what you're seeing. So you've been given some mathematical evidence. What do you think is going to happen? All right? But here's the cool thing. When we look at number 14 here, we're going to be adding additional values. Okay? Now, we know negative 1, 0, and 1. 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 But what happens when we do the numbers in between 0 and 1 and 0 and negative 1, right? Negative 1 half, well, this will just be the same, right? These are just the same. Whoops, that's a positive 1 half, my bad. But let's look at it cubed, right? Negative 1 half cubed, so times negative 1 half times negative 1 half. Well, that's going to be negative, positive, negative, a negative number. 1 times 1 times 1, 1 over. 2 times 2 times 2 is 8. Cool. Okay, so it's different in between. So even though negative 1, 0, and 1 are the same, in between there, we're going to have different values. That slope is going to be slightly different. Now let's look at it for the fifth power, right? So now it's negative 1 half to the fifth power. Okay, so I'm going to shortcut this a little bit. I'm not going to write it all out. Okay, so because that's just going to be 1 to the fifth power, 2 to the fifth power. We know it's going to be negative because it's odd. So 1 times 1 times 1 is 1, of course. Now 2 times 2 times 2 times 2 times 2, so it's going to be 8, 16, 32. Wow, look at that. So at negative 1 half, it's going to be much closer to our x-axis there, at 1/32. Okay? So go ahead and figure it out for the positive 1 halves. Now, here, it wants us to graph it. Okay? It wants us to graph it on these intervals using the information we had before. So let's say, y equals x, I'll do in purple. Well, y equals x is just going to be a straight line, right? We do 1, 1, 1, half, negative half, negative half. Okay. I am a little disappointed that they decided to use decimals instead of fractions, because we all know my love of fractions, but I will find a way to persevere. Okay, that's my straight line for y equals x. Now what about y equals x cubed? Okay, what were my values there? Well, this and this and this were all the same. But when I looked at what a half was, when I plugged in 1 half, what I got was an eighth. So I have to figure out an eighth here. So there's 10 lines here, right? 1, 2, 3, 4, 1, yeah, okay. So an eighth is about, it's about right here. I'm kind of guesstimating a little bit. And then a negative eighth is going to be about right there. And again, this is just a guesstimation. Okay. So my lines, it has to curve something like this to hit there, and then it's got to curve again like that to hit that. Okay. So that's my x cubed. Okay. Let's see if I have another color. I have another color. Here's pink. All right. So now I need to do y equals x to the fifth. And remember, this time is like 1/32. Like that's super close. Like these lines are tenths, right? These are 1/10. So this would be like 1/20th. So like 1/32, like here, man, it's like super close. And negative 1/32 is going to be like this. It's going to be super close to the line. And so how's that going to behave? While still hitting 1, 0, and 1. So it's going to go like this. It's going to be an even steeper here, and then flatter here, and then flatter here, and then steeper here, right? That's pretty cool, right? The purples are straight line, the browns are cubed, and our pinks to the fifth. And we can kind of see how the different power, right, to the first, third, or fifth power, all odd powers, first, third, and fifth, we get these different shapes. But we only really are able to see this when we zoom in, right? This whole graph is just from 1 to -1. It's such a tiny little field. But that's where all these interesting differences happens. That's part of why I love fractions, because all of this, we're working in the fractional realm. We're working in these tiny little numbers and seeing these really intricate things happening. You know, it's like looking in an ant farm of mathematics. I really enjoy it. Okay, so you're going to be doing that again for the next section, except now we're going to expand out to see what's happening at the twos. Okay, so we're actually going to zoom out a little bit out of my love of the fractions into a little bit of a bigger realm. But you'll see how those behave, and then you'll be asked to graph them here. All right, and then finally, we're going to be using exponents rules to simplify these expressions. This is just adding fractions like we've done before. These all have the same base, all have the same base, all have the same base. So all that we need to do is add our exponents. And all you need to do here is add a third to a sixth to a fourth. These will all end up with the common denominator of 12, right? Because 3, 6, 9, 12, 6, 12, 4, 8, 12, okay? So to get this to have a common denominator of 12, we need to multiply it by a special form of 1, 4 over 4. 4 over 4, so that's going to become 4/12. This needs to be 2 over 2 to become 2/12, and this needs to be 3 over 3 to become 3/12, right? You see that 1/3 and 4/12 are the same number, 1/6 and 2/12 are the same number, and 1/4 and 3/12 are the same number. So this ends up being 4, 6, 9/12. Which I can simplify because they both reduce by 3 to 3/4. This is our simplified answer for that one. All you're doing is adding fractions, which means finding common denominators, okay? Find common denominator. And denominator. Cool, and if you need help with that, there's a billion smarter math teachers than me doing all that sort of work for you to look up, but we should be able to find our common denominators at this point. All right, everybody, that's it for today. Work on your homework, persevere, and I'll see you in class.